This is a polar problem, also a calculator problem. Part A says find the area bounded by the curve and the x-axis. They give us the equation for the curve, r equals theta plus sine 2 theta. They also give us the limits. They say that theta is from 0 to pi. So then part A, finding that area. This is going to be polar area, so 1/2 the integral of r squared d theta. It is okay to just write r in this case, but I'm going to write the function sine 2 theta. Normally I would say don't do that, but a lot of times with polar curves there could be more than one curve and they could call them both r equals, but in this case they don't. And then the integral from 0 to pi, which are the limits that they gave us. And then since this is a calculator problem, we're going to use our calculator to evaluate this. So in my calculator, I will never need to be in any other mode other than polar mode. So then in y equals, I have x, did I say polar mode? We will never need to be in any other mode other than function mode is what I meant. And then radian mode as well. So making sure that I'm in radian mode. Here's my function, theta plus sine 2 theta. I just have x's for theta. And then I need 1/2 the integral, math 9, from 0 to pi. And then r squared, or the function that I have stored, which is r, in y1, integrated with respect to x, which then gives me this value, this 4.382. And that is the area of that inside that polar curve. And then part B says find the angle theta that corresponds to the point on the curve with x coordinate -2. So then part B, x is equal to r cosine theta. X is -2. R is theta plus sine 2 theta. And it's r cosine theta, so then times cosine theta. And we're going to use the calculator to solve this equation. I have to keep in mind that my equation, the input is theta, the output is an x value. In my calculator, the input is an x value, the output is a y value. So in my calculator, my x's are going to be thetas, and my y's are going to be the x's that I'm looking for, which means in my calculator, the x min and x max, which are the inputs, are going to be from 0 to pi. They're my thetas in my equation. And my y min and y max is going to be from -3 to -1. They're my x's in my equation. So then, using my calculator, I'm going to put r and then cosine theta, and then -2, and then I'm going to go to the window from 0 to pi, and then my y min is -3, my y max is -1. Graph. There's my function. There's y equals -2. Going to calculate the intersection. This is a point on the first curve. This is a point on the second curve. 1 point of intersection. The guess isn't going to matter. So then x equals 2.786. And I wrote x equals, but we actually solved not for x, we solved for theta. So theta equals. And then for part C, this says that dr d theta is negative for pi over 3 to 2 pi over 3. What does this fact say about r? Well, this is part C. Dr d theta being negative, dr d theta negative, a negative derivative means that our function would be decreasing. So it means r is decreasing. Then the next thing says, what does this fact say about the curve? So if I look at the curve from pi over 3, and this is an approximate, to 2 pi over 3, because r is decreasing, that means the curve is getting closer to the origin. So since r is decreasing, the curve is getting closer to the origin. Plus the r value is positive from pi over 3 to 2 pi over 3. You didn't have to state that, but if r is not positive, if r is negative and r is decreasing, then the curve is actually getting further away from the origin. And then the last piece, last part D, looking only from 0 to pi over 2, so only looking in the first quadrant, we're looking for the point with the greatest distance from the origin. So only looking at this part of the curve. And what we have is a closed interval from 0 to pi over 2. And we're looking for the greatest distance. We're looking for the absolute max. So 0 to pi over 2, where r is the distance from the origin. And so in order to figure out our critical value, we need dr d theta to equal 0. And dr d theta is given. Dr d theta is 1 plus 2 cosine 2 theta. And we're going to let our calculator solve this equation too. We actually could solve this one without a calculator, but since we're using the calculator here, we'll just let the calculator solve it. 1 plus cosine 2 theta, but using x's instead of theta. And we're going to set our window only looking from 0 to pi over 2. And then we want to see an output value of 0, so from -1 to 1. And then graph. Here's our curve. So I can calculate, we want to calculate the 0 from 1 to, and I'm going to scroll for the second boundary. Enter. Here's the critical value that we're looking for, 1.047. So our critical value, 1.047. And then we want to find the greatest value of r. So we're going to plug all of these values, r of 0, r of this 1.047, and r of pi over 2, back into, we're going to plug all these theta values back into r, where r is this given equation, theta plus sine 2 theta. So now I need to type that equation back in. X plus sine 2x, quit alpha y1 of 0, which is 0, alpha y1 of the value that we just solved for on the graph, alpha y1 of pi over 2. And here's the three values that we have. So 0, 1.913, 1.57. And again, I don't want to do all that work and not get the credit here. So I want to make sure that I summarize my table. The greatest distance from the origin, is, we're actually looking for the theta value. So occurs at theta equals 1.047. The points here This is going to be 1 point for the limits and constant. So are the limits correct, and did you write the 1/2? 1 point for the integrand. Did you use the r value, and did you square it? For polar area, 1/2 the integral of r squared d theta. And then is the final value correct? 1 point for writing this equation, the x equals r cosine theta equation. 1 point for solving for the theta value correctly. 1 point for the analysis that told us that r was decreasing. 1 point for the analysis that told us the curve was getting closer to the origin. 1 point for finding this critical value. And 1 point for our summary statement with justification.